This is a video on horizontal and vertical tangent lines. The question states, find all points of horizontal and vertical tangency to the curve x is equal to sine of theta minus theta times the cosine of theta, and y equals the cosine of theta plus theta times the sine of theta. So a line will be horizontal when its slope is 0, and a line will be vertical when its slope is undefined. So let's find the slope of the tangent line, which is the derivative dy over dx for the curve. So we have the formula dy over dx is equal to dy over d theta divided by dx over d theta. So let's find dy over d theta. The derivative of the cosine of theta is negative the sine of theta. And to find the derivative of theta times the sine of theta, I use the product rule. The derivative of theta is 1 times the sine of theta, and then plus theta times the derivative of the sine of theta, which is the cosine of theta. Now let's find the derivative of x with respect to theta. The derivative of the sine of theta is the cosine of theta, and then I use the product rule for theta times the cosine theta. Derivative of theta is 1 times the cosine of theta. And then I add theta times the derivative of the cosine of theta. So that's a minus sine of theta. So there's my derivative, but let's clean it up a bit. This is negative the sine of theta plus sine of theta. Those go away, and I'm left with a theta times the cosine of theta on the top. Similarly, cosine of theta minus cosine theta goes away, and I have a minus or a plus theta times the sine of theta on the bottom. So that means the derivative is theta times the cosine of theta over theta times the sine of theta. And the thetas cancel, and I'm left with the cosine of theta divided by the sine of theta. So remember, I'm finding the horizontal and vertical tangent lines. So let's start with the horizontal tangent lines. The horizontal tangent line occurs when the slope is 0 and a fraction is 0 when the numerator is 0. So I set cosine of theta equals 0 for my horizontal tangent lines. And that happens when theta is pi over 2, and then plus some integer multiple of pi. So I need to plug that in to x and y because I want points. So first thing, cosine of theta is 0. So the theta cosine theta goes away, and the sine of pi over 2 plus k pi, that oscillates between 1 and negative 1. So I get negative 1 to the k. So if I plug into y, cosine of theta goes away, that's 0. And then we have theta, which is pi over 2 plus k pi, times the sine of theta, which we said was negative 1 to the k. So now let's go for the vertical tangent lines. That occurs when the slope of the tangent line is undefined, so that means the denominator must be 0. So I set sine of theta to be equal to 0, and that happens whenever theta is some multiple, whole number multiple of pi. So I plug in k pi in for theta. Notice sine of theta is 0, so I get negative theta, and that's negative k pi, and then cosine of k pi oscillates between 1 and negative 1. So negative the cosine of k pi oscillates between negative 1 and 1. So that gives me negative 1 to the k plus 1 times k pi for negative theta cosine theta. So now let's plug into y, and cosine of k pi, that we said was negative 1 to the k, and then sine theta is 0, so that part goes away. So I can conclude that the horizontal tangent lines occur at the points negative 1 to the k, comma, negative 1 to the k times pi over 2 plus k pi. And the vertical tangent lines occur at negative 1 to the k plus 1 times k pi, comma, negative 1 to the k. And I'm done with the problem.